Sayadri Group of Institutions, a symbol of excellence.
Okay, I'm audible. Great. So we'll start. This is course objective. The course objective is very simple. That is, you have to acquire the basic knowledge of stress, strain due to various type of loading. So this will be your first chapter of stress, strain, and different types of loading. Second chapter will be shear force and bending moment diagram for transverse loading. Third, there will be bending, shear, slope deflection. Fourth, torsional. And fifth is principal stresses. And this concept you have to utilize for combined loading in last chapter. So combined loading will be like there will be three-dimensional loading, and you have to find out how the SFD PMD will affect the particular you can say object. These are some course objective outcomes. That is, after completing this course, what you get to know, what you are bound to, you can say study, or you are bound to get the knowledge of these things. That is, define various type of stresses, draw SFD PMD diagram, compute the slope deflections, calculate torsional shear stresses in shafts, and apply all these concepts in 2D and 3D kind of force systems. So this is the course outcome of this particular solid mechanics subject. This is a syllabus part, and these are the books which are recommended in your syllabus. That is SS Ratan, RK Bansal, and the Stephen Timoshenko. All these books, PDF are available in our blogspot. I'm going to upload right now. Actually, it is not available right now, but you'll get in 1-2 days. Okay, we'll just admit some students. Admit all. So these books are very important because as strength of material SS Ratan, 90% of the time the numericals come from SS Ratan. Then Dr. R.K. Bansal, we are using from our childhood. This is very essential book. And Stephen Timoshenko, if you are planning for MTech and PhDs, then you have to use this Stephen Timoshenko for this more knowledge. And these three books have been, you can say, they have been written in our. Yes, R.K. Bansal is given, SS Ratan is given, and in reference book, Timoshenko is given. Timoshenko and Young, Strength of Materials, CVS Publication, Singapore. Then there is another source of you can say lecture series, that is Dr. S.K. Bhattacharya from IIT Kharagpur, NPTEL web course material. So you can use this course material also. I'm going to share this PPT after completing up this lecture. So don't worry, don't write anything. You'll get all these PPTs directly in your Go group. As well as maybe I have shared one blog with some students. I'm going to share that also with you. That blogspot is okay. I'll share it again in your book, in your WhatsApp group. So we'll start with that. The next part is okay. Today's lecture will be quite bit theoretical because this is first lecture. I'm not going to take any numericals right now, but you all know these things. Concept of elasticity and plasticity. What is elasticity? Elasticity is very simple. That is, if some object has been pulled or pushed and it is again regain its shape, then it is called as elastic material. So property of material by which it return to its original shape and size after removing the applied load is called as elasticity, and material itself is elastic. Now in some of the students may ask, sir, which material is to be said to be elastic? Because maybe in your diploma syllabus you might be heard that is steel is more elastic than rubber. We see rubber is elastic material, it regains its shape again, but in case of steel, how it is possible? But if you will see in details, that is rubber has a specific property, that is after some loading, maybe 10 or 12 kilonewtons, it may get break, but in case of steel it may not, it will not get break up to 1000 uh, kilonewtons also, and it regains its shape again, so it is called as more elastic than the rubber. Plasticity, it is a different property. This property is also important because in case of pressing and forging it is needed. Characteristic of material by which it undergoes inelastic strain, that is permanent deformation beyond the elastic limit, is known as plasticity, and this property is useful for pressing and forging. In the next concept, direct and normal stresses. When force is transmitted through a body, the body tends to change its shape or deform. The body is said to be strained. Now, in layman's language, we can say that त्रास दिला आपल्याला कोणी डोक्यावर हे झालं की आपण म्हणतो आम्ही स्ट्रेस्ड आहोत, ठीक आहे, डायरेक्ट और नॉर्मल स्ट्रेस. So same case is there with materials also. If material is being stressed, material ला त्रास दिला, सॉरी फोन आला होता, ओके, मटेरियलला त्रास दिला तर त्याच्यामुळे काय होऊ शकतं, मटेरियलवर स्ट्रेस येऊ शकतो, अँड त्याच्यामुळे it changes its shape, and that's why it is called as a strained body. Okay, now we all know these notations. Direct stress is applied force divided by cross sectional area. So divided by sign is done, it is missing here. So unit is Newton per meter square. So Newton per meter square, Newton per mm square, Newton per meter square is called as Pascal. You might be knowing in fluid mechanics, we use this Pascal unit very frequently. But in case of SOM, we are going to use Newton per mm square as a unit. Newton per mm square will be your unit of Newton per mm square will be the unit of stress, and 1 Newton per mm square is equal to 1 megapascal. You have to remember for lifetime. 1 Newton per mm square. Yes. Hello. Okay. If you have any queries, you can ask directly.
अच्छा, कधी पोहोचली?
This is interactive class, so you can unmute yourself and you can talk directly with me anytime. So there is no problem if you will talk, because we have to feel like a class. No, right now we are in online process, but we have to feel like a class also. So this is direct and normal stress. We know this concept is drawing free body diagram. So if we'll take any cross section, in that cross section you will get to know that particular forces applied on that particular body will cause some stresses and strain in that body, and these stresses are maybe due to tensile force or maybe due to compressive force. So there will be two type of forces or stresses, direct stresses, that is one may be tensile and one may be compressive. Now what is strain? It is similar to stress. When the body is been applied with any load, there will be some change in its length, and if we can calculate the what is change in length per unit original length, we can call it as a direct strain or strain itself. Okay, so this is the simple concept of stress and strain. Strain is positive for increase in dimension and negative for reduction in dimension. If it is compressive, then it will be negative. If it is um, pulling load, then it will be a positive strain. Shear stress. We all know shear stress are produced by equal and opposite parallel forces, not in line. So if the forces are equal and opposite, but they are not in a single line, they are having different planes, then there will be shear stress acting tangentially on that particular area of surface. Okay. Now shear strain. It is measured by shear displacement divided by width or the angle by which it has been deflected. So if there are two forces acting here on AB surface and CD surface, and if there is C to C dash, there is a deflection or displacement of X, then we can define shear strain like this. So it is normally denoted by gamma and it is equal to X divided by L, or we can write it as tan phi. Okay. All these concepts have been, you can say, you have been familiar with. So I'm just rushing fast. Don't worry, I'm going to share this PPT with you also. Now, elasticity and Hooke's law. You have seen that elastic, what is elasticity or what is the elastic limit, etc. So Hooke's law is very important for, you can say, define the stress, strain, and the relation between stress and strain. The Hooke's law states that providing the limit of proportionality of a material is not exceeded, the stress is directly proportional to the strain produced. So whatever the stress will be directly proportional to the strain, and if we plot the stress strain graph, we'll get to know that it is a linear straight line, and that's why we define Young's modulus of elasticity as it is a constant of proportionality of stress upon strain. So Young's modulus E or Y, normally E, in 12th standard you might be having seen that it is Y, but in engineering we use at E, and it measures the stiffness of a material. The stiffness, or we can say the strength of material, we calculate from Young's modulus of elasticity. As an engineer, you should know what is the Young's modulus of elasticity of different materials by heart. Just like for steel, it is 200 to 210 GPa that you might be knowing. So this is a proportional limit, elastic limit, yield point, ultimate strength, and rupture strength. So this is proportional limit. P up to point P, it will behave like a straight line. Afterwards, up to elastic limit, it is having some curvature, yield point, ultimate strength or rupture strength. Ultimate strength or rupture strength, at that point, the material will get collapsed, material will get, you can say, broken. Okay, and this is modulus of elasticity. Just we have defined it. Stress upon strain. We know that stress is force per unit area, and strain is displacement per unit. Sorry, this is X means change in length per unit length. So it is WL by XA or PL by, we are going to modify it. The Young's modulus is called as the modulus of elasticity or stiffness, and it is measure of how much strain occurs due to given stress. So it is simply, you can say, it indicates that how much stress it can bear at that particular loading condition. Now, modulus of rigidity. Modulus of rigidity, it is also called as shear modulus. Similar to Young's modulus, shear modulus is the ratio of shear stress to shear strain. And Poisson's ratio. This Poisson's ratio is very important in your life, because we know that in one direction there will be elongation, but in other direction there may be contraction. So what we have to find out, that is due to directional force in one direction, what will be the change in the dimension of that particular object in other directions. So it is a ratio of lateral strain to longitudinal strain of the material. Lateral strain is nothing but, lateral is in which direction we are going to use major force. It is called as lateral direction. And longitudinal is perpendicular to that particular direction. So what will be the change in lateral strain to longitudinal strain is called as a Poisson's ratio. It may be denoted as mu or nu. It is mu, Latin symbol, or nu. Normally we use mu, and it lies between, okay, it lies between 0.25 to 0.34 for most of the metals. One homework for you, there is one material which is having negative Poisson's ratio. You have to find out from Google or anything. गूगल से फाइंड आउट करो, कहीं से भी फाइंड आउट करो. एक मटेरियल है जिसका म्यू निगेटिव है. म्यू निगेटिव हो नहीं सकता, हमारे तो दिमाग में रहता है, इंजीनियर्स always think that mu will not be negative, क्योंकि एक डायरेक्शन में आपका लेंथ बढ़ रहा है तो दूसरी डायरेक्शन में आपका डायमीटर कम होना ही चाहिए. लेकिन there is one material in which length also increases and diameter also increases. So you have to find out. This is your small homework. Now, three-dimensional stress system. Why we should learn this 3D stress system? Because there is one concept that is called as volumetric strain. So the volume gets changed. Just now we are seeing that that is due to that mu Poisson's ratio. We know that if there is directional force in one direction, there will be definitely change in other direction. So that's why volumetric strain is playing important role in our three-dimensional stress system. And that volumetric stress is nothing but, or volumetric strain is nothing but, it is a change in volume divided by original volume. And it is defined as, it is strain in one direction, EV, is equal to strain in x direction plus strain in y direction plus strain in z direction. Okay, so this is up to this is theoretical part which we have seen. And I'll just share one. All these books are available in our library, as well as all these books I'm going to share in this WordPress blog. If you will go on this blog spot, you will find, I'll just share my screen again. Yes. Okay, this blogspot is an initial stage. Just now I have uploaded some, you can say, notes, etc. I'm going to upload these books also, PDF books also. So if you'll go here, simple stress and strain, you'll get to know. Downloadable handwritten notes are there. I'll show that notes to you. Okay. Can you see the notes, or just I want to wait 1 minute. Yes. So these are handwritten notes. These are 4-5 years back notes. So you can refer these notes also. Just in simple language, so you can understand it properly. Principle of superposition, the principle and its numericals. These are simple numericals, but the difficult one will come in your exam. If you'll go again on this blogspot, I've started solving some numericals. Unit 1 numericals are there. So you can see here some numericals also. So you can utilize this blog as you can say as your property. You can use it. Also, you can solve some numericals, send it to me. I will upload these numericals, different kind of numericals on this blogspot. Okay. So today it was the first lecture. So I hope that you can see this smart board. We are going to use this smart board also within 1-2 days to solve numericals. So here a smart board is there. You can directly solve your numericals. If you will send us some numerical, I can solve here and I can record them, and I will upload these things on YouTube channel also. Okay, so smart board is also available with us, so we can use this smart board for your betterment. And if you are not able to, you can say, attend the lectures in regular time, you can attend at in the evening. We are going to record this because many of the students have requested that, sir, if the recording is available, then it will be okay for us. So thank you very much for joining this lecture. And if anybody wants any to give suggestions, etc., you can unmute yourself and tell me. Any suggestions?